You know, right now, just beneath our feet, there's this invisible world, just teeming with life. It's like a microscopic army, and it has the power to heal our planet. So today, we're going to go underground and figure out how we can engineer this tiny army to clean up some of our planet's biggest messes. Let's dig in.
We've all heard the call to action, right? Plant more trees. It feels so simple, so direct. It's supposed to be our best shot at fighting climate change. But here's the thing. There's a huge hidden flaw in this plan. In way too many places, these trees are being planted in poisoned ground. And frankly, they're just not making it.
So what's going wrong here? I mean, it's not the tree's fault. The problem is the soil we're asking them to live in. Think about it. Decades of industrial activity have left behind this toxic legacy that even the toughest little saplings just can't overcome by themselves. And it's really crucial to understand just how big this problem is. We are not talking about a few isolated spills here and there. Research from folks at the International Journal of Engineering, Applied Sciences and Technology, or IGEAS, shows this is a widespread, persistent contamination from countless sources. These chemicals, they don't just fade away. They stick around, soaking our soil and water for years and years. Let me put it this way. You wouldn't expect a world-class athlete to run their best race while breathing in toxic fumes, would you? Of course not. And it's the exact same thing for a tree. Its roots are everything. They're its lungs, its lifeline. So when the soil is just choked with nasty stuff like acrylamide or petroleum hydrocarbons, the tree basically suffocates. It can't get nutrients, it can't breathe, it can't grow. Simple as that. Okay, but what if we could clean that soil before the tree's roots even had to deal with it? What if we could send in a microscopic cleanup crew to detoxify the land first? Well, it turns out nature already thought of that. So let's meet these tiny heroes. The solution has a pretty cool name, bioremediation. And at its core, it's just the process of using living things, we're talking bacteria and fungi, to break down these complex, really harmful pollutants. They essentially eat the pollution, turning it into basic, harmless stuff like water and carbon dioxide. And this isn't just any old microbe, it's a whole specialized army. On the roster, you've got your specialists like Enterobacter. This one is fantastic at tackling industrial chemicals. Then you have the heavy hitters, the first responders like Pseudomonas and Acinetobacter, who you call in for those really stubborn oil spills and other nasty petroleum gunk. So how in the world do they actually do it? Well, it's not magic, it's just brilliant biology. These little bacteria have spent millions of years evolving to see these complex chemicals as, believe it or not, a food source. They've developed this incredibly powerful metabolic engine that is literally fueled by pollution. Which brings us to the big question, right? When we say a bacterium eats a toxin, what does that actually look like on a molecular level? How does it take something so hazardous and turn it into something completely harmless? Okay, I know this diagram looks a little intimidating, but the secret weapon here is actually pretty simple. Enzymes. A bacterium releases a very specific enzyme, something like monooxygenase, that acts like a pair of molecular scissors. Just watch how it targets those strong chemical bonds, holding a pollutant molecule together. It just snips them apart, and that starts a chain reaction that breaks the entire thing down into much safer stuff. We can really boil this whole incredible process down into 3 basic steps. First, the bacteria has to physically grab onto the pollutant. Then, it sends out those specialized enzymes we just saw to break the complex molecule apart. And finally, and this is the best part, they absorb those smaller, simpler pieces and use them as food to grow and multiply. More food means more bacteria, which means the whole cleanup process actually speeds up over time. It's brilliant. Now, knowing that this process exists is one thing, but figuring out how to actively use it to our advantage, that's the next great leap. How do we make sure our underground army is in the right place, at the right time, and totally ready for battle? This is where a strategy called biopriming comes into play. And this is where it gets really, really clever. Seed biopriming is a total game changer. Instead of just sticking a seed in the ground and crossing our fingers, we can preload it with its own microbial bodyguard. We literally coat the seed with a custom-made mix of beneficial bacteria. This gives it a built-in defense system and a cleanup crew from the very moment it starts to sprout. So let's just look at these 2 approaches side by side. The old method, it's basically a shot in the dark. You put a vulnerable little seedling in the ground and just hope it can tough it out against the toxins.
But with biopriming, we're actually engineering success. That seed is armed with microbial allies that create this protective little zone around it, actively breaking down pollutants so the new root has a safe space to grow.
And get this, it's not a one-size-fits-all solution, it's incredibly precise. Just take a look at this data on Enterobacter cloacae. Its power to break down the industrial chemical acrylamide totally depends on the pH of the soil. You can see its peak performance is right around a neutral pH of 7. If it's too acidic or too alkaline, its efficiency just drops off a cliff. This just goes to show we have to understand the specific conditions of a site to send in the right microbe for the job.
So where is all this heading? Well, this research is pointing to a future where restoring an ecosystem isn't just about planting trees. It's about actively engineering the entire soil community for success, from the microbe all the way up. And that leads us to this powerful new idea: precision pairing. I mean, imagine scanning a polluted industrial site, identifying the exact chemical that's causing the problem, and then selecting the perfect plant and microbe combo to fix it. Maybe it's a specific poplar tree bioprimed with Enterobacter for one site, and then a totally different type of grass primed with Pseudomonas for an oily roadside. It's targeted, intelligent, ecological restoration. The possibilities here are just enormous. We could reclaim land we thought was permanently lost to pollution. We can create forests that aren't just surviving, but are actively cleaning their own environment. And what's truly mind-blowing is this idea of vertical transmission. These good microbes can actually be passed down from the parent plant to its seeds, creating generations of plants that are born with this built-in resistance and cleanup crew.
And that leaves us with a really fascinating thought to end on. We're getting better and better at understanding the human microbiome, right? Using probiotics to improve our own health. So what if we could do the same for our planet? Could we one day prescribe a specific cocktail of microbes to heal a sick forest or a polluted river or a damaged landscape? That is the future this science is building. Pretty powerful idea to think on.